Okay, yes, hi students, very good evening everyone. Very good evening everyone. Welcome to the session. Welcome to Om Institute. Okay. So welcome to the next session in the champion series where you have an important topic from signal and system to be discussed for today, and that is one of the very important topic I would say from signal and system, and that is the Fourier transform. Okay, that is the Fourier transform, the important topic of Fourier transform. So this session, let me tell you that this session will be serving as a quick revision of Fourier transform for you. Okay, right. Okay, so a quick revision of the Fourier transform for you, wherein we revise the important formula and target the questions. Okay, target the questions. So yes, Sandeepan, correct. Of course, I will, because I'm calling it as a revision session, I will not derive it, but yes, okay, whenever I go to any question, I will explain the complete concept of applying the property, because what type of questions you get from Fourier transform is mostly property based. Okay, several good questions you get. Okay, so with complete detailed conceptual explanation, I will present to you. Okay, right. Very good evening, Sai Vikas. So let's get moving ahead and let's revise the Fourier transform in this particular session. Okay. So yeah, before that, important updates for all of you that yes, the Om Institute brings to you the online live crash course for GATE 2025 for both EE and EC branches. It's a mega opportunity. Okay, for those who are lagging behind in syllabus, okay, to complete the syllabus in a short tenure of time, that's 2 months. Okay, the duration of this course is 2 months. That is, it's a 60-day target course. Okay, validity is of course 4 months. So you can even watch the videos after the GATE exam. You may target BARC or any other examination. Okay, so 4 months is the validity, and the batch starts from 24th of November. That is the next Sunday, and the fee is 5499. Okay, as well as if you are an old Om student, taken any offline or online course from Om the last year or any of the previous year, the fee will be 3499. And if you are a current Om student enrolled into any of the offline or online batches of Om for this year, okay, so your fee will be 2499. Of course, with this you will get the free online test series package. Okay, and the platform will be Om Live app, and for more details you can visit our website, or also or maybe you can contact the number 9515694053 for further details. Right. Yes, Pawan, don't worry, we will bring up the marathon session also, where we will target the quick revision of the entire subject. Okay, we'll target the quick revision of the entire subject. Such marathon also will bring to you. Also, dear, if you register before 20th of November, okay, up to 20 November, you will get flat 10% additional discount on the fees that I have mentioned here. Okay, so yes, if you're sure about the crash course, better to enroll before the 20 November. Now, let's get started, guys. Fourier transform, as you know, let me start with the formula. Okay, the Fourier transform of a signal xt, okay, which is denoted by x omega, or we also commonly represent them as the Fourier transform pair. Okay, we represent them as the Fourier transform pair by the double-sided arrow. We say that xt has the Fourier transform x omega, or we say that, or we also write it this way, xt having the Fourier transform x omega by the double-sided arrow, which clearly means that if xt has the Fourier transform x omega will have the inverse Fourier transform, that is xt, where the Fourier transform x omega, okay, f of xt, Fourier transform of xt, given by the formula integral minus infinity to infinity xt e power minus j omega t dt. Okay, and the inverse Fourier transform, okay, of x omega, okay, that will be of course xt, will be given by the formula 1 upon 2 pi integral x omega e power j omega t d omega, right? So these are the basic Fourier and inverse Fourier transform formula. Now, as I told you, to be very honest, okay, whenever any question is coming to you, not only in GATE but in any of the competitive exam, okay, it will be mostly around properties using some basic signal Fourier transform. Okay, like unit step, unit impulse, exponentials. There are some signals whose Fourier transform must be known to you. Okay, so I will talk about those important signals also. What is the condition for the convergence of the Fourier transform? The Fourier transform of a signal will converge, okay, if it follows the following Dirichlet's condition. The first one being more mathematically important to you. Okay, second and third are more to clear, more to just say that the function should be well defined. There should not be any randomness in the function. So we say that xt has a finite number of maxima and minima within any finite interval of time, and xt should have a finite number of discontinuities within any finite interval. Okay, now this one for mathematically more important, that the signal should be absolutely integrable. For the Fourier transform to exist, signal should be absolutely integrable. That is, integral mod xt dt should be finite. Integral mod xt dt should be finite. Okay, right. Now as I was telling you, the Fourier transform of some important signals, if I just go to it, that okay, the Fourier transform of some important signals must be very clearly known to you. Okay, let me come up here. Okay, let me present to you some important Fourier transform pair. Okay. Okay, today also we'll have practice questions, Ganesh. But yeah, on a whole signal system, I'm telling you, we'll have another revision session for a whole signal and system. Okay, so for important Fourier transform, see, there are several signals. Fourier transform, I'm telling you, is an important topic, not only for question. Of course, direct questions are pretty much expected, but indirectly, towards the study of LTI system, towards the, study of filters, a lot of areas Fourier transform find the application. Okay, so, because directly, indirectly, it is very important topic. Okay, so whenever some basic signals are coming up, you should remember the Fourier transform pair. Every time you will not use the formula integral xt e power minus j omega t dt. So what are some of the signals whose Fourier transform must be known to you? Okay, so there is a set of important Fourier transform pair, and then there is a set of properties. You must know both of them, and then we start the question. Okay, then we start the question. Of course, if it was a complete detailed Fourier transform, so I will derive each and every one of them, but I think it's not required at this moment, since we are focusing more on the revision sessions for GATE, which is just going to come up in the next 2 months of time. Okay, the GATE examination. Okay, so say the very important signal, impulse signal, Fourier transform 1. Okay, for 1, the Fourier transform is 2 pi del omega. This is also the duality property. This comes up with the duality property, which I will indicate. Okay, so Fourier transform of impulse is 1, the Fourier transform of 1 is 2 pi del omega. If A has the Fourier transform B, B has the Fourier transform similar to A. E power minus at ut Fourier transform 1 upon A plus j omega, provided A must be positive, otherwise Dirichlet's condition will fail. The signal will not be absolutely integrable if it is e power plus of something, because if A becomes negative, minus minus plus. Okay, so e power minus at ut Fourier transform 1 upon A plus j omega, e power minus A mod t Fourier transform will be 2A upon A square plus omega square, again A being positive. Okay, t e power minus at ut Fourier transform 1 upon A plus j omega whole square. Okay, unit step, ut Fourier transform 1 by j omega plus pi del omega. Okay, signum function Fourier transform is 2 by j omega. Okay, exponential, complex exponential e power j omega naught t Fourier transform 2 pi del omega minus omega naught. With this, we also derive the Fourier transform of sinusoids, that is cos omega t and sin omega t. Okay, so for cos omega naught t, it is pi del omega minus omega naught plus del omega plus omega naught. And for sin omega naught t, it is written as pi upon j del omega minus omega naught minus of del omega plus omega naught. So, I will also share you this entire PDF in the Telegram. So this PDF will also be serving as a quick formula booklet for Fourier transform, where you will see all important Fourier transform written in one place, as well as the properties, and then we learn through questions. Of course, we'll start questions quickly. Okay, rect t by t. Now, this is a standard way of defining rectangle signal. I will specify to you. Okay, what is this rect t by t? Okay, so when I say rect t by t, okay, it is a rectangle signal. It is a rectangle signal. Okay, centered at origin, having the total width of t. Having the total width of t. So total width of t means it is from minus t by 2 to t by 2. Total width is t. Okay. Similarly, when I define a signal tri t by t, tri for triangular signal. Okay, tri t by t is a triangular signal. Again, symmetric, centered at the origin. Okay, centered at the origin. Okay, located from minus t up to plus t. If it is tri t by t, it is taken from minus t up to the plus t, having the total width of 2t. Having the total width of 2t. Now, rect t by t having the Fourier transform t sampling omega t by 2. Okay, you can also write in the sinc function format, because you know the relation between sinc and sine. Okay, when I sinc and sampling. When I write down sampling x function or sampling theta function, Sampling theta function is given by sine theta by theta. Okay, when I write down the sinc theta function, okay, the sinc theta function is written as sine pi theta upon pi theta. Okay, and definitely this sinc theta function can be written as sine pi theta by pi theta. So if you put pi theta by pi theta here, then only it becomes sampling pi theta. So sinc theta is equal to sampling pi theta. Okay, so you can convert to sampling and sinc, between sampling and sinc. Okay, Fourier transform of rect t by t is t sampling omega t by 2, and for tri t by t it is t sampling square omega t by 2. Okay, next important pair, sampling at. Okay, again coming from dualities. For sampling at, it is given by pi by a rect omega by 2a. Okay, this one is important, especially in the analysis of low pass, ideal low pass filter. Sampling square at pi by a tri omega by 2a, e power minus at square, Gaussian signal. Okay, e power minus at square, Fourier transform is pi by a root e power minus omega square by 4a. Root pi by a e power minus omega square by 4a, which is again a Gaussian function. Okay, Fourier transform of Gaussian is Gaussian. Out of this, few pairs are very, very important that you must always remember. Okay, even if I just wake you in midnight, okay, you should be able to tell that Fourier transform. Okay, so of course all of them are important, but some of them being very important is, okay, of course impulse, that is automatically known to you. Impulse has the Fourier transform 1. Okay, Fourier transform for e power minus at ut. Okay, Fourier transform of constant 1. Okay, then t e power minus at ut. Okay, unit step signal. Okay, moving to the next, sinusoids. Okay, lot many questions you will find around rectangular signal. Many questions you will find around rectangular signals, property based. Okay, and it's dual pair, sampling at Fourier transform, because I told you this is especially good, will bring good questions around low pass filter questions. Okay, the sampling at having the Fourier transform pi by a rect omega by 2a. Gaussian also important. Okay, so these are something which must be always remembered. Even if I wake you at midnight, you should be able to just suddenly say, okay sir, this is the Fourier transform of the given signal. These are the important ones. Okay, more important ones. Okay, which I have highlighted. Okay, now what are the Fourier transform properties? Let us come to the properties of the Fourier transform, the different properties that you must be knowing. Yes, Sheikh, you can put down your question. So if x1t has Fourier transform x1 omega, another signal x2t has the Fourier transform x2 omega. Okay, this looks like a typo error. Okay, then first linearity, basic linearity. Whenever signals are added or subtracted, okay, or scaled, multiplied by any constant. Okay, so for a1 x1 Fourier transform a1 x1, a1 x1 omega. For a2 x2t Fourier transform a2 x2 omega. If they are added, Fourier transform added. If they are subtracted, Fourier transform will also be subtracted. It is applicable to both plus and minus. Right? Time shifting to xt minus t naught has the Fourier transform e power minus j omega t naught x omega. Time scaling, x of at having the Fourier transform 1 upon mod a x omega by a. 1 upon mod a x omega by a. Within it, if I put a equal to minus 1, we get the time folding case as well. Time folding x minus t will have the Fourier transform x minus omega. Okay, so I have specified the property. Okay, I have specified the signal and its Fourier transform. Right. I'll tell the Telegram channel name also. Mukherjee, just wait. Okay, duality. That is what I was telling you, important one. Duality. Capital XT has the Fourier transform 2 pi x minus omega. You must always, be aware how to apply the duality. You must always be aware. Just for a moment, I will pause. Okay. Like I told you, like one of the important case, e power, let's take minus 2t ut. What is the Fourier transform for e power minus 2t ut? The Fourier transform is 1 upon a plus j omega. That is 1 upon 2 plus j omega, because I have taken a equal to 2. Right? This is what I have taken, a equal to 2. Okay. What does duality says that? Okay, if you have the same function in the time domain, if I convert the omega function to the time domain, okay, omega equal to t. So I get the function 1 upon 2 plus jt. Okay. So that is what I told earlier. See, xt has the Fourier transform x omega. Then capital XT, that means converting the omega to the t function, will have the Fourier transform 2 pi small x minus omega. This will have the Fourier transform 2 pi. Small x means the original time function, okay, will be taken and t replaced by minus omega. T replaced by minus omega. So e power minus 2 into minus omega u of minus omega. Okay, so what is the Fourier transform for the complex signal 1 upon 2 plus jt? 1 upon 2 plus jt, and we will take more numericals later. This is just one explanation. It will have the Fourier transform 2 pi e power plus 2 omega u of minus omega. 2 pi e power plus 2 omega u of minus omega, right? Okay, similar to it, the important one I told you, na? Rect of t by t. Already I told you important. What was the Fourier transform for rect of t by t? T sampling omega t by 2. Okay, if I apply duality onto it, duality is one of the very important properties. So I'm just taking one or two examples around it before we go to the actual question. So if this omega function is converted to the time, okay, t sampling, okay, t into capital T by 2, okay, that becomes a sampling function in the time domain, will have the Fourier transform, 2 pi, okay, small x, that is this time function converted to omega by putting t equal to minus omega, 2 pi rect of minus omega by t. Okay. Now, okay, the formula we commonly write in the sampling AT form. So if I put t by 2 equal to a, so t becomes 2a. 2a sampling AT. Normally we write down the formula in the form of sampling AT. Okay, sampling AT. So t becomes 2a. So 2a sampling AT has the Fourier transform 2 pi rect of minus omega by t or rect of omega by t is same, because just few minutes back I've shown you the rectangular waveform. It is even symmetric. Rectangular signal is even symmetric. Okay, so rect minus omega, rect plus omega will be the same. Okay, so 2 cancel. What is the Fourier transform for sampling AT? I've already told you. This is how we actually calculate. For sampling AT, Fourier transform becomes pi by a rect of omega by t, and t is 2a. Pi by a rect omega by 2a. Same thing I told you in the table. Same thing I told you in the formula table. Okay. This is how we come to some very, very important Fourier transform pair using the duality concept. Okay. Using what? Using the duality concept. Correct, everybody? Okay. So that is why this duality is one of the most important properties, I would say. Okay, to derive lot of important Fourier transform pair. Conjugation, if xt has the Fourier transform x omega, as I told, x conjugate t, x conjugate minus omega, this will lead to several symmetry property which I have written separately. We'll come to symmetry, very, very important property. Okay, alone this conjugation property not important, but application, if it like to find out symmetry properties is very important. Okay, differentiation. So the first derivative d by dt of xt has the Fourier transform j omega x omega. So if you keep differentiating, j omega factor keeps multiplying. So for nth derivative, the Fourier transform is given by j omega power n x omega, right? J omega power n x omega, right? Good evening, Sharath. Okay, integration, integral x tau d tau, integral minus infinity to t x tau d tau will have the Fourier transform x omega by j omega plus pi x0 del omega. Integral x omega by j omega plus pi x0 del omega. Frequency differentiation, also known as the t times property. Frequency differentiation, or this property is also commonly known as t times property. Okay, so t into xt, t times the signal. Okay, so t into xt is having the Fourier transform j d by d omega of x omega, differentiation in the frequency domain. J d by d omega of x omega. Frequency shift e power j omega naught t xt has the Fourier transform x omega minus omega naught. Okay, time shift corresponds to phase term, exponential term in frequency domain. Frequency shift corresponds to exponential term in the time domain. Again, like duality. Convolution in time corresponds to multiplication in frequency. Multiplication in time will lead to convolution in frequency. So x1t convolution x2t, Fourier transform x1 omega into x2 omega. x1t into x2t, Fourier transform 1 upon 2 pi x1 omega, convolution x2 omega. Okay, modulation, xt cos omega naught t will have the Fourier transform x omega plus omega naught plus x omega minus omega naught by 2. Okay, now symmetry property, I was telling out of this one, conjugation. Okay, because if a signal is real, okay, what do you mean by real signal? What do you mean by real signal? If it is real, the signal and its conjugate is same. Okay, if z is real, so z and z bar is same. Conjugation of a real number is same as itself. And if these two are equal, their Fourier transform also equal. So x conjugate minus omega equal to xt Fourier transform x omega. Okay, or we put it this way, okay, by putting the conjugation on other side. So what is x minus omega? Is x conjugate omega, and this is what is known as conjugate symmetry. This is what is known as conjugate symmetry. Okay, x of minus omega Fourier transform for negative frequency is equal to the conjugate of the Fourier transform of positive frequency. Okay, related just through a conjugate operation, we call it as conjugate symmetry. So these are some very, very important symmetry properties that I'm mentioning here. Okay, directly, indirectly, in fact, many times for factual questions also, property based question also very important. Okay, if a signal is complex, Fourier transform in general is complex. If a signal is real, Fourier transform is complex but following conjugate symmetry. If a signal is real, Fourier transform will be complex in nature. Okay, but following conjugate symmetry. Okay, complex and conjugate symmetric. If a signal is real as well as even, then the Fourier transform will also become real. Then it will not be complex. Okay, and the Fourier transform will also be even. Okay, if a signal is real and odd, the Fourier transform is pure imaginary and odd. Pure imaginary and odd. And again, applying duality, if a signal is conjugate symmetric, then the Fourier transform should be real. Okay, real signal has conjugate symmetric Fourier transform. So conjugate symmetric signal will have a real Fourier transform. This is again duality. This is again duality, but these are important symmetry property. Okay, many a times property questions are expected and made out of it. Indirectly also we will see, we can expect numericals, but yes, this is important even for direct results. Okay, so please kindly note them, and anyways, don't note, I'll share you the PDF as I mentioned. Okay, so this PDF will be a quick, always a quick revision guide for Fourier transform for all of you. Okay, next important properties around Fourier transform is the application to find area, because Fourier transform formula we know is integral xt e power minus j omega t, and as soon as I put omega 0, e power 0 will become 1. Okay, so if I put omega equal to 0 here, we get integral xt dt. What I am left with is integral xt dt. Okay, and that is basically area of xt, area under the curve. Okay, so area under the curve xt can also be obtained, if it is difficult to integrate it, can also be obtained by knowing the value of the Fourier transform at omega equal to 0. When I say this x0, what is this x0? It is the value of the Fourier transform at dc, that is omega equal to 0. Okay, and similarly by the inverse Fourier transform formula, okay, if you need area of x omega, so 2 pi shifted on the other side, it can be 2 pi x0. This x0 means the value of the signal xt at initial time t equal to 0. Okay, Parseval's theorem, whose questions I'll come a little later, but first we'll say some important property based question. Okay, yes. Okay, if there is an energy signal, what is the energy signal? Signal having finite energy is an energy signal, we know. Okay, we calculate the energy in the time domain as integral mod xt square dt. Integral mod xt square dt, okay, which is again equal to 1 upon 2 pi integral mod x omega square d omega. Its energy can also be calculated in the frequency domain by the knowledge of its magnitude spectrum. Okay, 1 upon 2 pi integral mod x omega square d omega. Similarly, for a power signal, we calculate, the power as 1 upon time period, energy in one time period divided by time period, which is equal to summation mod ck square, where ck is the Fourier series coefficient. Okay, today we will only take Fourier transform. Okay, then if required, we'll plan one session for Fourier series separately, because again, that has a different approach of taking the question. Different, model of questions are there in Fourier series, and different type of model of questions are there in Fourier transform, right? Okay, fine. Chalo. Out of this also, dear, properties are again almost many properties are important. But if I highlight, some things which are more important out of the Fourier transform property, okay, some things which are more important out of Fourier transform, so time shift, because sometimes you directly get the question on the shifting and scaling application. Okay, duality, as I mentioned, very, very important. Okay, conjugation as a property for numerics is not important. Okay, differentiation important. Okay, integration actually more important. Frequency differentiation property, t times based question, very important. Okay, frequency shift, okay, moderately important. Okay, this is where more numericals are turned up, and convolution also important. Okay, symmetry property anyways I told you very important. Hey, this also I should rather call it as very important. Okay, okay, and area under the curve, simple applications these are. Okay, some important Fourier transform pairs are already written in front of you. Okay, out of which important and very important also separately highlighted. Okay, now here it is a question for you. Here it is a question for you. Okay. Determine the Fourier transform of xt equal to d by dt of 2t e power minus 2t ut. Now see whose Fourier transform is known to you. Out of this now, whose Fourier transform is known to you. Just look into it and decide whose Fourier transform at least is known to you. Okay. Just evaluate the Fourier transform of this signal. Yeah, just complete. Okay, Gajendra says answer A. Okay, so some stances are started coming up. Let us take this. Determine the Fourier transform of xt equal to d by dt of 2t e power minus 2t ut. So we can start with t e power minus 2t ut, right? We can start with t e power minus 80 ut having the Fourier transform what? T e power minus 80 ut Fourier transform 1 upon a plus j omega whole square. 1 upon 2 plus j omega whole square. 1 upon 2 plus j omega whole square. Okay. Right. Now, if I take 2, so I'll multiply 2 on both the sides. 2 into this. But now next is differentiation of this. Okay. So what is the derivative property? Good evening, Raj. Very simple derivative property. So if you take the derivative of the signal, okay, d by dt of 2t e power minus 2t ut, what will be the Fourier transform? That Fourier transform multiplied by simply j omega. So my answer should be 2 into j omega upon 2 plus j omega whole square. Okay. So that is option number A. Correct answer, Gajendra. 2 j omega upon 2 plus j omega whole square. Correct answer A, right? The very correct answer is A. Okay. Okay, we'll plan EMFT questions as well. Okay. So this is what correct answer is option number A. Next one. Determine the Fourier transform of xt is equal to 4t upon 1 plus t square whole square. Okay, 4t upon 1 plus t square whole square. Good evening, Ramu. Okay, 4t upon 1 plus t square whole square. Okay, so now, 4t, if you just focus, this is not any of the function that was given in the standard formula list. I've given you a standard formula list, Fourier transform pair, that must be known to you. And then the previous one was, standard formula, t e power minus 2t ut mixed with one differentiation property. Okay. Normally questions will not be direct Fourier transform pair, mixed with some property. Definitely mixed with some property. Okay. Definitely mixed with some property. Right. So let us see what is the case here. Okay. Now whose Fourier transform, see this is not directly one of the known signals, but do you have any Fourier transform in which contains omega square plus 1 in the denominator? Omega square plus 1, omega square plus a square. Okay, yes, Gajendra, this is duality based, but which pair to be taken for duality? Start with e power minus a mod t. What is the Fourier transform for e power minus a mod t? is 2a upon a square plus omega square, with a being positive. This is one of the pairs we noted, right? Now in this, okay, if I want omega square plus 1, so I will take a equal to 1. So e power minus mod t. If I take a equal to 1, so e power minus mod t. Fourier transform, if I put a1, so 2 upon 1 plus omega square. Okay, a equal to 1 means positive, so formula is applicable. Okay, now further, okay, I need the differentiation. Okay, let me first apply duality and then maybe differentiation will come into role. Okay, so let me apply the duality. What does duality says? Okay, convert the omega to the time function. So you have 2 upon 1 plus t square. 2 upon 1 plus t square. This will have how much Fourier transform? 2 pi small x. That means take the time function and put down t equal to minus omega. So e power minus modulus minus omega. But modulus minus omega is same as modulus omega. Modulus of negative number is same as that of the positive number. So 2 pi e power minus, but inside modulus, modulus minus omega is modulus omega. Okay. So let me pick up this pair here once again. What I am trying to tell you is we have 2 upon 1 plus t square, correct? We have 2 upon 1 plus t square. This has the Fourier transform 2 pi e power minus mod omega. 2 pi e power minus mod omega, correct? 2 pi e power minus mod omega. Now, in this, what I need is 1 plus t square whole square. There is some x in the denominator. You want to make it to x square. That can happen by differentiation. That can happen by differentiation. Okay, so, let's differentiate this. Okay, let's differentiate this. Okay, so d by dt, again a differentiation property, d by dt of 2 upon 1 plus t square. If you differentiate the time function, what will happen? J omega to be multiplied in the frequency domain, j omega x omega. Now let us see the derivative of this 1 upon x minus 1 by x square. So minus 2 upon 1 plus t square whole square. 1 upon x derivative minus 1 by x square, but this is not x. This is 1 plus t square. So again to be differentiated with time, chain rule. So this will be giving 2t additional. This will be giving 2t additional, right? And this is what actually I want, 4t. I want the 4t, this will give you 4t. Okay, and right side you have 2 pi j omega e power minus mod omega. Okay, so this gives 4t upon 1 plus t square whole square. Shift this minus on the right side. Okay, minus 2 pi j omega e power minus mod omega. Let me match the option. Okay, minus j 2 pi, yes, j shifted first, minus j 2 pi omega e power minus mod omega, option number D. Option number D. Good question, based out of duality and basic Fourier transform pair. Right. So good question based out of that, I would say. Next question. Yeah, next question. Here it is. Let xt has the Fourier transform x omega. Let xt x omega be the Fourier transform pair. The Fourier transform of the signal x3 x5t minus 3 in terms of x omega. Okay, the Fourier transform using property, direct property question it is actually. Okay, and similar property question we can find in the GATE exam as well. Okay, so let there be this signal yt. Let me call this as some signal yt dear. Okay, let us call this as yt, which is x of 5 minus 3. The question is, what is the Fourier transform of yt? That is y omega. Where xt has Fourier transform x omega. The general property, no signal and no Fourier transform given, general property based it is. Sai Vikas says answer A. Answer started coming up. Okay, so we start with xt, and this signal xt has the Fourier transform x omega. Okay, now precedence rule. Even when you are sketching the signals, there are two elements here, shifting and scaling. Okay, this represents shifting and this represents scaling. Okay, what to apply first? mathematically no constraint. You can apply any property first. Even when you're sketching, you can do anything first. But always shifting first and scaling will be, better to avoid errors. Okay, so we make a precedence rule, shift and scale. We make a precedence rule, first shift, then scale. First shift, then scale. We make that precedence rule. Okay, so if I do the first shifting, first, so see what will be the transformation. The signal xt, okay, on shifting will be xt minus how much? How much is the shifting value? 3. So xt minus 3. This will have how much Fourier transform? Okay, xt minus 3, Fourier transform x omega. Okay, xt minus 3, so x omega e power minus j omega t naught to e power minus j omega into 3, correct? Now scale. Prasad also says answer A. Okay, now scale. First shift, then scale. Okay, so scale means t will become 80. T will become 80. A here is 5, so t will become 5t. And what is the x80 scaling property? Okay, x80 scaling property. Admin also says A. So, sorry, not admin. Adam says A. Okay, so if there is scaling x80, the Fourier transform 1 upon mod A x omega by A. 1 upon mod A. 1 upon mod A, scaling factor is 5. So 1 upon mod 5 means 5. X of omega by 5. The entire frequency function on the right side, omega will be replaced by omega by 5. Okay, so x omega by 5, this also. Sometimes that is what the student's mistake will be done. X omega by 5 e power minus j omega 3. No, e power minus j omega by 5 into 3. Every omega on the right side will be replaced by omega by 5, and hence option number A, okay, as disclosed by some of you, is the correct answer. 1 upon 5 x omega by 5 e power minus 3 j omega by 5. Okay, be careful, this should not be at least your answer. Option number C. Okay, right. So yeah, correct answer Sai Vikas, Prasad and Adam. A is the very correct answer. Okay, we can be then moving towards the next question. Sometimes the relation can be in the F domain also. This was omega domain. Okay, now look into it. GATE 2024 current year 2 marks question. It is a GATE 2024 current year 2 marks question. Okay, consider two continuous time signals xt and yt as shown below. Xt and yt. Okay, so now previous one was little bit more straightforward, because what is yt in terms of xt? Xt is a signal given, then you need to find Fourier transform for x 5t minus 3. Now here xt has the Fourier transform xf given in the frequency hertz domain. Xf is the Fourier transform of xt. Then what is the Fourier transform for yt? Okay, but what is the relation between xt and yt? That you have to highlight using the waveforms given. So that is one additional step. Okay, that you have to highlight using the waveform given. Okay, so let us do this. Okay, xt and yt. First of all, look into the duration of xt, 0 to minus 1. That means duration 1 unit. Here it is duration 4 units. Okay, this duration, if I just observe, okay, this duration is actually 1 unit on the xt. Okay, it is same triangle, inverted triangle. Okay, but triangle, so this is 1 unit. Here the duration of the triangle given is 4 unit. Okay, this is 4 into 1. Okay, so 4 times expansion. Okay, 4 times expansion. Okay, so what should be yt? If it is expanded means x of t by 4. Expansion means x of t by 4. Okay, this is not the final form. Just I am telling that expansion has to be there. Expansion has to be there. Okay, expansion has to be there. Okay, and that too by 4 times. And expansion 4 times means xt by 4. Compression 4 times means x4t. That is what we know. Okay, so that is what expansion is there. But not only expansion, if you just expand this xt, okay, so 0 into 4 is 4, minus 1 into 4 minus 4. So it should be between minus 4 to 0, but it is minus 2 to 2. That means some shifting is also there. Okay, how much shifting? Okay, so first let us make the center. Here the center of the triangle is 0. Okay, the center is minus 0.5. So let's make the center first of all. As 0.5. That means I need to right shift. Center at origin, that means I need to right shift by 0.5. So listen to me, what will I do? Okay, I'll write it here separately. Yt. First what I need, right shifting by 0.5. Right shifting by 0.5 will make it xt minus 0.5. Keep listening. So once I make xt minus 0.5, I will get a triangle here. Okay, this will be right shifted to 0.5. This will be right, this will be minus 0.5, correct, and this will be the center. Okay, this is the triangle I get, okay, by right shifting. Then let me expand the triangle. How much time? 4 times, as I told you. Let me expand. So when you expand 4 times, 0.5 into 4 will be 2. Minus 0.5 into 4 will be minus 2, correct? So let's expand by 4 times. And expand means t by 4. Expand means t by 4. Expanding 4 times. Okay, then once you expand 4 times, now you will get a triangle which will be between minus 2 to 2, but that is downside. Only thing is you have to multiply it by minus 1. Okay, so that amplitude reversal will occur. Right now it is going to minus 1. You have to make it go to plus 1, all positive amplitude, to multiply it by what? Multiply it by minus 1. Okay, this is the relation between the two signals. You can check carefully now. Okay, so that I start. Okay, so that I start the Fourier transform property then. Okay, what is the yt? Ask me if you have any doubts here. Yt is minus of x of t by 4 minus 0.5. Okay, x of t by 4 minus 0.5. Okay, so again I will start with xt, and this signal xt has the Fourier transform x omega. Okay, the Fourier transform of first shifting, na? Last question. First shifting, as I told you, so x omega e power minus j omega t naught, to e power minus j omega 0.5. Okay, then x of t by 4, then scaling. Okay, x of t by 4 minus 0.5, so scaling 1 upon mod a. How much is the scaling factor? 1 by 4. X a t, a is 1 by 4. So 1 upon 1 by 4. Everywhere omega will be replaced by omega by a. Everywhere on the right, omega will be replaced by omega by a, and a is 1 by 4. So x omega upon 1 by 4 e power minus j. This omega also omega upon 1 by 4 into 0.5. Okay, right. Last but not the least, let me place minus. So minus on the right side also, the minus of x t by 4 minus 0.5. This is the signal yt. This will have the Fourier transform. Minus you place, 1 upon 1 by 4 will be 4. So minus 4 x of how much? Omega by 1 by 4 will become 4 omega. E power minus j. This is how much? This is how much? 4 omega. Okay, into 0.5. So 2 omega basically. Okay, 4 into 0.5. So e power minus j 2 omega. This is correct. Okay. Right. So your answer should be minus 4 x 4 omega e power minus j 2 omega. Oh, sorry. I forgot it is in F domain. No problem. It is in F domain. Okay, so minus 4, you can replace this omega. You can replace this omega by 2 pi f. So it becomes e power minus j. When I place this omega 2 pi f, e power minus j 4 pi f will come. Okay. Right. X omega or x of 2 pi f. Okay. Normally, inside the function, we write it xf only. X omega, when you put omega 2 pi f, then it becomes x 2 pi f. This 2 pi is constant. So x is a function of what? This is a functional representation. Here we say x is a function of omega. Here what do we say? 2 pi is anyways constant. So x is a function of frequency f. Okay, so it is, commonly specified as xf only because it is a functional form. Okay, so minus x minus 4 x of 4f e power minus j 4 pi f. Now let us see what is the correct answer. Minus 4 x of 4f e power minus j 4 pi f. Okay, with 4 pi f, option number A. Okay. Option number A. Check it out once. Okay. GATE 2024 2 marks question. Property based. Okay, so there are two steps actually in the question. Property is the second step, but first is relating the xt and yt waveform. Okay, that is the first thing that you should know. The relating xt and the yt waveform. Relating xt and the yt waveform. Correct, everybody? Relating the xt and the yt waveform. Okay, let me know for any more doubts. Okay, this is what is a GATE 2024 2 marks question. Okay, fine. Right, let's move ahead to another question here. Okay, consider the signal xt equal to 1 for mod t less than 1. Find the Fourier transform. Direct question basically. Okay, then we will build some questions around it. Xt equal to 1, mod t less than 1. What does it mean? Xt equal to 1 for mod t less than 1. What is the meaning of mod t less than 1? Magnitude of t less than 1. So t, of course, if it is positive, less than 1. If it is negative, it is between minus 1 to 0. So t is actually between -1 to 0 or 0 to 1. For both of them, magnitude will be less than 1. Na? Okay. So when you say mod t less than 1, so t is between -1 to 1. Any number between -1 to 1, once you take the magnitude, will have the magnitude less than 1. This is the signal xt. So what is the signal xt? Okay. If I want to sketch the signal xt, what is the signal xt? What is the signal xt? It is 1 for mod t less than 1. That is for any value of t between -1 to 1, the signal xt is equal to 1. Okay, and this is nothing but a rectangular waveform. This is nothing but a rectangular signal. It is equal to rectangle, okay, between -1 to 1. How much is the width of the rectangle? The width of the rectangle is 2 units. The width of the rectangle is 2 units. So we can call it as rect t by 2, a rectangle between -1 to 1. Okay, so the signal given here is a rectangular signal whose Fourier representation is sampling function, we know. Okay, whose Fourier representation is sampling function, we know. Okay, let us recall, and I told you one of the most important formula of the Fourier transform pair, rect t by t. Okay, t sampling omega t by 2, t sampling omega t by 2. So what should be the Fourier transform for this signal? What is the Fourier transform of this signal? So what is the value of the duration capital T? It is equal to 2. So 2 sampling omega into 2 by 2. Okay, so this 2 will get cancelled. Answer is 2 sampling omega. Answer should be 2 sampling omega. Okay, and many times options are in the sine format. So we know sampling theta is sine theta by theta. So this is convertible to 2 sine omega by omega. 2 sine omega by omega, option number C. It is 2 sine omega by omega, option number C. It is correct. Okay, it is equal to 2 sine omega by omega, and hence option number C. Hence it is option number C. Right? Just a second. Next one. Okay, let's move ahead to the next question. Okay. Yes, Adam, correct answer C. The correct answer is C. Now, one more question, you can majorly say directly onto it. One more question majorly or directly onto it, I would say rather, is this one. Let's take this question. Okay, a signal is represented as xt is equal to 1 for mod t less than 1 and xt is 0 for mod t greater than 1. Just now I explained you, just now I explained you that this signal xt, okay, is rect of t by 2. This signal xt has rect of t by 2. So the Fourier transform, we can use it, Okay, just now we derived, so we can use the Fourier transform 2 sampling omega. Okay, because it is the same data. Xt equal to 1 for mod t less than 1. It is a rectangle signal. So x omega is 2 sampling omega. The x omega here is 2 sampling omega. What is the Fourier transform of x2t convolution xt by 2? So now see, it is a mixture of two property. One is the scaling property and then convolution property. Scaling property and convolution. So dear, first let me apply the property. Okay. Fourier transform of yt. What is the Fourier transform of yt? I will call it as y omega. I will call it as y omega. Equal to, what is the Fourier transform for x2t? Xat, 1 by mod a, x of omega by a. So 1 by 2, x of omega by 2. What is the Fourier transform for xt by 2? Okay, again 1 upon mod a, 1 upon half, x of omega upon half. Correct. Convolution in time, multiplication in frequency. Convolution property, convolution in time, the Fourier transform should be multiplied. Okay. So what is the Fourier transform of the signal yt? This is given by, so 1 upon 2 and this will become 1 upon half 2. So they will actually cancel. So you have x of omega by 2 multiplied by x of omega upon half will be x2 omega. Dear, what is x? The 2 sampling omega function. Okay. So this is equal to the x omega by 2. What is the x omega by 2? If you place omega by 2, so this becomes 2 sampling omega by 2 multiplied by, okay, x2 omega. Okay, so x2 omega will be 2 sampling 2 omega, omega replaced by 2 omega. So your answer should be 2 to 4. Okay, and see, your answer will be 4 sine omega by 2 sine 2 omega divided by omega square. Okay. 4 sine omega by 2 into sine 2 omega divided by omega square. So answer is option number A. Correct answer is option number A, right? Okay. Option number A. Okay. Yes, Adam, correct answer, option number A. Okay. Okay. Yes, we'll try to do Madhvi as much as possible. Okay. So yeah, answer is 4 upon omega square sine omega by 2 into sine 2 omega. Sine omega by 2 into sine omega. Right. Next question. Next question again based out of this rectangle function only. Based out of the rectangle function, have a look into this. Okay, consider the signal xt equal to 1 mod t less than 1 and 0 otherwise. Find the Fourier transform of yt. Okay, find the Fourier transform. Okay, yt as shown. Find the Fourier transform of yt as shown. Yeah, this is the first of signal, and signal started with the important topic revision, that is Fourier transform. Okay, so find the Fourier transform of yt. Now again see what is this signal doing here. Okay, this is again the same signal xt equal to 1 for mod t less than 1. Okay, xt equal to 1 mod t less than 1, that means it is a rectangle signal. Okay, it is the rectangle signal, rect of t by 2. Already explained, rect of t by 2. Okay, and if xt is rect t by 2, again let us use the result 2 sampling omega. Okay, 2 sampling omega. Now what is the signal yt? Understand what is the yt signal, how to relate with the signal xt given. Yt is a straight line. Okay, it is a straight line of the form mx plus c. Okay, mx, x means t here, sorry, it is a function of time. So mt plus c. Okay, straight line relation mx plus c. Okay, m is the slope and c is the y-intercept. Okay, what is the y-intercept? It is passing through origin. Okay, so no y-intercept. Y-intercept is 0. Okay, slope. So slope, let's calculate now. Let's take this portion. Okay, height of this portion 1 unit and base is also 1 unit. The slope is 1 upon 1, height upon base, which will be 1. Okay, so actually what is yt? Actually what is yt? So this relation, if m is 1, becomes only t. C is 0, na? This only becomes t. So yt equal to t. But if I leave now yt equal to t, what it means? If I leave the answer as yt equal to t, it means yt equal to t throughout for all values of time. But no, yt is equal to t only from t equal to minus 1 to 1. Okay, only from t equal to minus 1 to 1. Okay, only from t equal to minus 1 to 1, very clearly shown in the picture. Very, very clearly shown in the picture. To see what is the yt. Yt equal to t from t between minus 1 to 1. Yt equal to t from t equal to minus 1 to 1. We can now write this as yt equal to t into 1. Okay, see how I manipulate this signal. Yt is t into 1. Okay. Okay, when minus 1 less than t less than 1. Okay, now for a moment let me remove this. Okay dear, if I remove it, okay, if I remove it, how much is this signal known as? How much is this signal known as? This is the same signal, previous one. This is the same signal. Oh, where is that gone? Yeah, this signal, xt equal to 1 minus 1 less than t less than 1, correct? Xt equal to 1 minus 1 less than t less than 1. Okay, so how much is this signal? This is the rectangle signal again. Okay, this is the rectangle signal. Now, let me multiply this factor again. What is multiply? T. So that means I am highlighting this much of the part as a rectangle signal. Okay, so in that format, what is the yt? Is t into rectangle signal. Rectangle t by 2, the width was 2. So which property? T times property, frequency differentiation property. This is a frequency differentiation property. Okay, rect of t by 2. Rect of t by 2 Fourier transform already known. We derived it right now, 2 sampling omega. What you should remember is the Fourier transform of rect t by t. Whatever is the capital T given, correct? Okay, so here it was given as 2. So we already written the solution as 2 sampling omega. Now t rect t by t, t times property. Okay, t rect of t by 2. Okay, t times or frequency differentiation property. What is the Fourier transform for txt? What is the Fourier transform for txt? is given by j d by d omega x omega, frequency differentiation, or also known as the commonly known as the t times property. Okay, d by d omega, this will be y omega. The Fourier transform of yt is y omega. J d by d omega of 2 sampling omega. To differentiate, let me again write sampling omega as sine omega by omega. Okay, and apply the numerator by differentiation rule, u by v rule. Okay, numerator by differentiation rule. Okay, so this will be, take the 2 outside, 2j, denominator will be squared, denominator constant, differentiation of sine will be cos, and minus sine, numerator constant, differentiation of denominator omega will be 1. Okay, so what is the answer I am left with? Let us see the option. It will be 2j format, cos omega by omega. Okay, this is 2j. Okay, the first term omega cancelled, cos omega by omega, and next, how the next option is arranged? Yes, sine omega by omega square, correct. Okay, next is simply sine omega divided by omega square. So option number B is what is matching here completely. Option number B, 2j cos omega by omega minus sine omega by omega square. Option number B. Yeah, option number B completely matches with our calculation, right? Yes, Ram Kumar, correct. So what you are now getting is property based question using some standard signal, property based question. Okay, right. That is what Mukherjee, yes. Okay, that is why I have specifically taken question based session. I first told you the properties and formula, of course. Okay, but you know, with questions only you learn things, and at the end moment, especially questions are more important. Okay, yes, Adam, correct answer B. Okay. So let's keep learning. Let's add on to our knowledge more and more. Okay, through these properties. Okay, application only. You know, any mathematical subject, especially like signal and system, is a hardcore mathematical subject. Okay, you can get the command by application of question, just by, you know, reading the set of formulas. Of course, that is important. That is why I started with some basic formulas and property. Okay, but only, you know, reading that formula and property will not help you. Maximum some 1 mark simple question you can solve, but not all variety of question. Okay, but not all variety of question. No, Vaditya, crash course will be online only. The crash course will be online manner only. Okay, live online manner. Consider a signal defined by xt equal to e power j tan t for mod t less than equal to 1 and 0 for mod t greater than 1. See, GATE 15 2 marks question. Okay, but again you notice, the similar signal, not exactly similar, but you know, some same conditions are there. Okay, I'll just wait, Sandeepan. You can search by my name, but I'll share you the Telegram link. Okay, just wait for it. Okay, just wait for it. See, let me see if possible I can share right now. Yes, why not? Okay, so where is that? Just wait for a moment. Here it is. Yes, this is the link of the Telegram as well I have shared now. Okay, yes, come on. Okay, so xt is e power j tan t for mod t less than 1. What is the Fourier transform? GATE 15 2 marks question. Okay, look into it, the GATE 15 2 marks question. Okay, so what is the xt e power j tan t, okay, for mod t less than 1. Okay, what is mod t less than 1? Again, t is between -1 to 1. Okay, so xt is e power j tan t, okay, when t is between -1 to 1. Okay, let me write down the xt as e power j tan t into 1. We can write anything into 1. Okay, Adam and Sai Vikas are ready with the answer, that is A. We can write it as e power j tan t into 1 minus 1 less than equal to t less than equal to 1. We can multiply any quantity by 1. That's what I have done here. Okay, that's what I have done here. Okay, now again, for a moment, if I erase this, what do I get? A signal which is 1 minus 1 less than equal to t less than equal to 1, which is a rectangle signal. Okay, this much part is rectangle, to be multiplied by what? E power j tan t. Okay, to be multiplied by this much part is again rectangle signal, to be multiplied by e power j tan t. So let me write down here. Now what is my signal xt is e power j tan t to be multiplied by rectangle signal having the width of 2, because it is there from -1 to 1, the total width 2. Total width 2 means rect t by 2. Okay. Now dear, e power exponential term in the time domain, the which property? Exponential term in the time domain, frequency differentiation property, e power j omega naught t into some signal xt will have the Fourier transform x of omega minus omega naught, opposite sign. If it is e power plus j omega naught t, here it is omega minus omega naught. Okay dear. So what is the Fourier transform of this signal? Okay, Fourier transform of this signal x omega. What is the rect t by t Fourier transform? Rect t by 2 Fourier transform we already calculated, 2 sampling omega. Okay, only if it is rect 2 sampling omega, so exponential term will create the frequency shift omega minus omega naught. How much omega naught? It is 10. So answer is 2 sampling omega minus 10. Okay, now sampling converted back to sine, I think. Yes, options are in sine format. 2 sine omega minus 10 upon omega minus 10. Sine theta by theta. Sine theta by theta. 2 sine omega minus 10 upon omega minus 10. Option number A very clearly. It is option number A very, very clearly. Without any doubt, correct? Option number A very, very clearly. Okay. Let's move to the next question then. Okay. Let us move to the next question here. Okay. Have a look into this next question. For the signal xt shown in the figure, find x0. Okay. Capital X0. And then integral minus infinity to infinity x omega d omega. Okay. What is shown? Okay. Yes, Ramkumar, A correct answer for the previous one. What is shown is signal xt in the time domain. Fourier transform not given. Question is x capital X0. Capital X0 means x omega at omega equal to 0. Capital X0, Fourier transform. So which property? It is the area based property. It is the area based property. The value of the Fourier transform at 0 at DC frequency gives the area of the signal xt. Okay, now here xt is known and it has a very simple shape. So we can directly calculate its area. We can directly calculate its area. Okay. How much is the area of this? Okay, how much is the area? Okay, there is only a triangular cavity. Suppose I make it flat. Okay, if this was flat, then it is a rectangle. If it was flat, then it is a rectangle having the height 2, base 4 unit. Having the height 2 and base 4 unit. Okay, if the cavity was not there, if it was flat. Okay, now this cavity means this much of the triangular portion will be removed. And what is the area of triangle? Half into base into height. So see, what is the base of this triangle? 0 to 2. Okay, 2 units. And height of the triangle, see height, only between 1 to 2. Okay, the height will be 1 unit. Height will be 1 unit. So 2 cancel, 8 minus 1, 7. The first answer is 7. Straightforward question it is. Okay, straightforward. Yes, Sai Vikas, 7 is the correct answer for first one. Now next one. What is integral x omega d omega? Integral x omega d omega is given by, again, the second result of the area property, 2 pi x0. Okay, 2 pi into value of the signal xt at initial time. Okay, okay, and that is known to you. Xt is given means you can just observe here. Okay, what is the value of the signal at time 0? This value is given as 2. Okay, this value is given as 2. So 2 pi into 2, that is 4 pi. The next answer should be actually 4 pi. The first is 7, the next being 4 pi. Okay, area property based question. Okay, the first is 7, the next answer should be 4 pi. The next answer should be equal to the 4 pi, correct? Next one should be equal to the 4 pi. Okay, done. Okay, let's take the next question then. Let x omega be the Fourier transform. GATE 24 1 mark question. Let x omega be the Fourier transform of the signal e power minus t power 4 cos t, where t is from minus infinity to infinity. What is the value of the derivative of x omega at omega equal to 0? Okay. See, this is not any of the common signals that I have given in the table. E power minus t power 4. E power minus t power 4. No. If it was t square, then we can think about Gaussian multiplied by cos. It is e power minus t power 4 function. None of the common signals, none of the standard signals that you know. Okay, what is the value of the derivative of the Fourier transform only at omega equal to 0? Okay, whenever I need any Fourier transform, whether Fourier transform of direct of derivative of x omega, anything, the value of the derivative of x omega at omega equal to 0, and whenever omega equal to 0 means area property, you can think. Okay, results at omega equal to 0 or t equal to 0 are related with the area properties, are related with the area property. Now, value of the derivative of x omega, the value of the derivative of x omega at omega equal to 0, at omega equal to 0. Okay, right. First of all, let me say that the derivative of x omega, listen to me, what I need is, let there be the derivative of x omega, which is suppose y omega. Okay, which is the derivative of x omega, d by d omega of x omega. So what I need, okay, the question is the value of this derivative at omega 0. Okay, so what I need is y0. What I need is y0. Okay, now what is y0? Okay, the area property y0 means area of the yt signal in the time domain. Do I know the yt signal? Okay, do I know the yt signal? Let's work out. Okay, let's work out some properties can be applied. Okay, xt, if xt has the Fourier transform x omega. Now, first of all, you want differentiation of x omega. You want differentiation in frequency domain. So, automatically which property? Frequency differentiation property. Frequency differentiation property. Frequency differentiation property, that is t times property also. So, txt has the Fourier transform j d by d omega of x omega. I don't want j here, na? There is no j here in our question. I only want derivative of x omega. So, take the j on the left side. 1 upon j txt has the Fourier transform d by d omega x omega. Now, what I am telling you is, I have given this the name of y omega. So, this becomes yt. This becomes yt. So, what is the yt? What is the yt? Okay, 1 upon j. Let me write 1 upon j as minus j txt. Okay, minus j txt. Okay, minus j txt. Right. Okay, the value of the derivative at t equal to 0. Let's work out the value of the derivative of x omega at omega equal to 0. Okay, now what is minus j t into xt? Okay, that is minus j into t into xt. Okay, into t into xt, where xt is copied here. E power minus t power 4 cos t. Okay. Okay, now what I need is area of yt. Okay. Okay, Adam says option number, Adam says answer A. Okay, now next I need is area of yt. Okay, next what I need is area of yt. Again, this is not any standard signal whose area I remember. If it is some, triangle, rectangle, we directly write down the area. But okay, let's work out what is the area. Area is given by the basic formula integral minus infinity to infinity yt dt. Integral minus infinity to infinity yt dt. Okay, can we highlight something about yt here? Okay, yt is minus j into t e power minus t power 4 cos t. Dear, if you write down y minus t, what will be the result? Minus j into minus t e power minus of minus t whole power 4 cos of minus t. Okay, so what is y minus t? Okay, I'll take one minus outside, then still you have minus jt inside. Minus t power 4 is same as t power 4. Cos minus theta is also cos theta. Okay, so what is the result? Is minus of where I started from, minus of yt. That means odd symmetry. It's a good question. Y minus t is actually minus yt, meaning the function is odd symmetric. Okay, and because it is odd symmetric, the basic integration property says that integral minus a to a, whether it is minus infinity to infinity or any other minus a to a, integral minus a to a for odd symmetric function is always 0. Integral minus a to a for odd symmetric function is always 0. Integral minus a to a for odd symmetric function is always 0. Okay. Integral minus a to a for odd symmetric function is always 0. That is the point to be noted here, correct? That is what is the point to be noted here. Integral minus a to a odd symmetric function is always 0. Done? Okay. Right. So correct answer is 0 here. Correct answer is 0 here. Good one it is. Okay. Next question. Let's take on to the next question now. Let's take on the next question. GATE 14 2 marks question. Okay. Again, some good property based question it is. For a function gt, it is given that integral gt e power minus j omega dt is omega e power minus 2 omega square. Okay. Now yt is given as integral minus infinity to t g tau d tau. Then what is integral minus infinity to infinity yt dt? Okay. Right. Say the doubt, Mukherjee. Which point? Okay. कौन से point पे problem है? Specify that so that I can help you better. Okay. A lot of steps while taking the question. Okay. So now, yeah, by parallel, let me start this question. Yt. Now, what is yt? Is integral minus infinity to t g tau d tau. Okay. Then integral minus infinity to infinity yt dt. Again, area of yt. What is this expression? Okay, this is again equivalent to area of the yt. Okay, or I can say that it is again equivalent to what? Okay, it is again equivalent to the value of the Fourier transform at omega 0, because area of signal is value of the Fourier transform at DC frequency. Okay, before the DC frequency, at the DC frequency. Okay. At the DC frequency. On the basis of this, let's try to solve. But what is y omega? First, we need to find by this relation. Okay, find by this relation. Dekho, this is Mukherjee. This is basically a odd symmetric function property. Okay, what I have done is, okay, y minus t in the given yt. Now I just put y minus t. So this is minus t. This also minus t. This also minus t. But look into this calculation. Minus t whole power 4 minus 1 power 4 will be plus 1. Na? So only t power 4 left. Cos minus theta we know is cos theta. So here we get cos t. Okay. So now effectively if you see what happens, this minus t I write down minus outside. Okay. So even if I take this minus outside, this minus jt e power minus of t power 4 cos t. Okay. This much bracket term is same as the yt. Okay. So what I have got, y minus t is minus yt, which is known as odd symmetric function. And this is an integral result. Okay, very important integral property. Look into integral properties. Integral minus a to a yt dt. What happens when the function is odd, when the function is even? Whenever it is odd symmetric function, answer would be 0. Answer would be 0. Okay. Chalo, let's come back. Yeah. So I need y omega at omega 0. But first, let's judge about y omega. To get the omega equal to 0 value, first let's judge the y omega. Okay. So what is yt given to me? Let us take it from here. Yt is integral g tau d tau. Okay, so integration property. Integral g tau d tau will have the Fourier transform g omega by j omega plus pi g0 j omega, g0 del omega. Sorry. Integration property. Integral of this signal g. Integral g tau d tau. The Fourier transform is given by g omega by j omega plus pi g0 del omega. Do I know the g omega? Yes. Hey, what is this? Integral minus infinity to infinity e power minus j omega t dt. Dear, this is what? Okay. This is Fourier transform formula only. Na? What is this? This is known as the Fourier transform of which signal? Gt. So this is g omega. Okay. So what they are indirectly telling that there is a function gt whose Fourier transform is omega e power minus 2 omega square. Right? Na? Indirectly, this function is Fourier transform function only, Fourier transform formula only. Okay, so what is g omega, dear? This function is known as the g omega, that is equal to omega e power minus 2 omega square, then whole divide by j omega plus pi g0. So what will be g0? Dear, if this is g omega, what will be g0? If you put omega 0 here, okay, it's 0 only. Okay, so what is this y omega, dear? What is y omega? Question almost done. Here omega cancelled. E power minus 2 omega square by j. Next part is 0. So only this is y omega. Okay. Now what I need? Y omega at omega equal to 0. At omega equal to 0. So here let us put omega equal to 0. Here I put omega 0, to e power 0 upon j, e power 0 is 1, so answer is 1 upon j, which is equal to minus j, correct? Answer is 1 upon j, which is equal to the minus j. Very correct answer, option number B. Yes, Adam, correct answer, good going. Okay, the very correct answer is option number B, undoubtedly. Okay, dear, option number B it is. Yes. So correct, this is what is good property applications. All these questions showing you good property applications. Okay, showing you the good property applications. Okay, showing you what? Showing you the good property applications. Okay, chalo. Let us come to another good question. GATE 17, 2 marks. Another good question. Okay, although it is a filter based question, but if you have the fundamental knowledge of Fourier transform, you can solve such questions. Especially that is the reason I am taking this question. Some questions on LTI system or LTI filters, okay, and on continuous time filter, especially if you have the fundamental Fourier transform knowledge, you can solve this question. Okay, let us see. It's a good question. Okay, but Fourier transform clear means this question can be solved. A continuous time signal is given to you. 4 cos 200 pi t plus 8 cos 400 pi t, where t is in seconds, is the input to a LTI filter. Okay, is the input to a linear time invariant filter whose impulse response is given to me. Okay, whose impulse response is given to me. 2 sine 300 pi t upon pi t for t not equal to 0, for t equal to 0, 600. Let me first understand this function, dear. Okay, what is this function? Okay, sine theta by theta feeling is coming, na? Okay, sampling. Okay, but to convert to sampling, I should have how much? This is 300 pi t, so here I should have 300. So I'll divide and multiply by 300. So I'm writing it as 2 into 300. Okay, multiplying numerator, denominator both by 300. Okay, divided by 300 pi t. Okay, now this is sine theta by theta sampling. So this becomes how much? 2 into 300, 600 into sampling function. Sampling 300 pi t. Okay. Now this definition, even if not given, that is okay. For t equal to 0, 600, dear, because what is sampling 0 value? Sampling 0, sine 0 by 0. So when we solve the limit rule, limit x tending to 0, sine x by x is always 1. Okay, so sine sampling 0 is always 1. So if you put sampling 0, t equal to 0, sampling 0, 1, 600 into 1, 600. So they have specified clearly, but even if not given, no problem. Okay. So what is my impulse response now? What is my impulse response? It is 600 sampling 300 pi t. Sampling 80 is the Fourier, sampling 80 is the impulse response, okay, for a low pass filter actually. Why? Okay, basic Fourier transform, nothing to mug up. Why a low pass filter or something? See, we just know what? We know the Fourier transform of sampling 80. Okay, I told you important pair, the Fourier transform of sampling 80. We derived it using duality. Today I have shown you this pair using duality. This is given by the formula pi by a rect omega by 2a in the frequency domain rectangle. Okay, so dear, if ht, what is the ht given to you is some 600. Okay, sampling function, sampling 300 pi t. Okay, so what should be the Fourier transform? Okay, what should be the Fourier transform? Okay, h omega, it becomes 600 multiplied both the sides. Now write down sampling 80 formula. So pi by a, pi by 300 pi. Okay, rect of omega by 2a. So how much will be 2a? 600 pi. Okay, so this becomes how much? Pi by cancel, 600 by 300. 2 rect of omega upon 600 pi. What is the sketch of this one? What is the sketch of this Fourier transform? How much is the sketch of this Fourier transform? How much is going to be the sketch of this Fourier transform? How much is the sketch of this Fourier transform? Let me just do it quickly. Okay, because it's a rectangle function, so we can, sketch this quickly, and that is in the omega domain. Okay, so this is omega and this is h omega. Okay, dear. So look into the rectangle function. Rect of omega by 600 pi. Omega by 600 pi. This is the total duration. Okay, what is written in the denominator? Total duration of rectangle 600 pi means minus 300 to 300. Maintaining the same symmetry, there should be a rectangle of minus 300 pi, starting minus 300 pi up to 300 pi, and having how much of amplitude? 2. Having how much of amplitude? 2. Okay, rectangle means this constant flat curve. Okay, Now that means now you see any frequency, okay, which is now applied to the system. You send any input to the system having some frequency omega. If that frequency is less than 300 pi, it will be passed with the gain 2. And if any frequency greater than 300 pi, how much is the gain of the system? How much is the gain of the system? 0. Okay. How much is the gain of the system is 0? Because, see, because normally the output when you solve in time domain, it is the input xt, convolution with the ht. So what is the Fourier transform? Okay, it is x omega into h omega. Convolution in time is multiplication in frequency. This h omega is the frequency response. The Fourier transform of impulse response is defined as the frequency response. The output is input into gain. We can call it as a gain term. So when you are solving in frequency domain, output is input into gain. Okay. But if the gain of the system is 0, output will also be 0. Okay. And hence we call this characteristic as an ideal low pass filter, which will pass any frequency up to the cutoff frequency. This is cutoff frequency 300 pi. Okay. Any frequency, okay, any frequency omega less than omega c in the input, okay, will be passed with how much gain? With the gain of 2 units. Any frequency which is greater than omega c will be, if you say passed, but with how much gain? 0. Because for omega greater than omega c, h omega is 0. So for any omega greater than omega c, it is passed with 0 gain, means it is not passed. Output will be 0. That means such a frequency is said to be rejected. It does not appear in the output. It does not appear in the output. Okay. So by simply using this logic, what is the input given to me? It is simply an ideal low pass filter question. Let me write down the input. 4 cos 200 pi t. There are two parts here. 4 cos 200 pi t. Okay. Plus some 8 cos of how much? 8 cos 400 pi t. 8 cos 400 pi t. This is what is the xt given to me. Okay. Now this has two different components. What is the first frequency? Omega c. 200 pi. Okay. Not omega c. This is simply the omega of frequency of the sinusoid. Okay. Sin omega t. Omega is 200 pi. This is again some sinusoid cos omega t. Omega is 400 pi. This 400 pi is greater than cutoff frequency. So what will happen? This will be rejected. This frequency omega is within the cutoff frequency. So this will be passed. With how much gain? If it is passed with how much gain? 2. Because h omega value is 2. Okay, output is input into gain. So if it is passed, it will be multiplied by 2. Output will be 2x omega. Output will be 2x omega. Here also I can write down. Output is equal to 2x omega. Okay, for omega less than omega c. Okay, but if omega greater than omega c, output will be x omega into 0. Okay, the output will also be 0. Output will also be 0. Okay, or mod omega less than omega c, even negative frequency can be there. Okay, correct. This is what is the true analysis here, right? So what is the output then? So what is the output? Okay, the output is given by 4 into, it will be passed with how much gain? 2. Okay, 4 into 2, okay, cos 200 pi t. And the other part, it is not passed. The other part will be rejected. So that will not appear in the output. So what is the output expression? 8 cos 200 pi t. Okay, 8 cos 200 pi t is my answer. 8 cos 200 pi t is my answer. Okay, they are asking the maximum value of modulus yt. So that will be 8. Okay, by cos theta maximum value is 1. So for 8 cos theta maximum value is 8. Okay. They've taken the modulus because cos theta can be positive, negative. So maximum value of mod yt. Okay. Maximum value of mod yt is clearly equal to 8 because maximum value of mod cos theta is 1. Right. So the answer is 8. That's it. Answer is 8. NAT question, GATE 72 marks, IIT Roorkee designed this GATE 17 paper. It's a good question on the fundamentals and applications of Fourier transform. Okay, on the fundamentals and the application of Fourier transform. Correct, dear? Okay. Also a quick reminder. Okay. And before I tell you the next important thing, yes, the online live crash course, okay, the live manner online batch for GATE 2025. Okay, if you want to cover up the GATE 25 syllabus in a fast track course, if you are lagging behind with the syllabus, or if you are done with the syllabus but want a quick revision, okay, a quick revision, okay, so you can join this crash course which starts 24th November. It is having a total 2 months duration, that is 60 days. Okay, validity 4 months. I mean, means you can even watch the classes, okay, from 4 months up to 4 months from your date of purchase, because after GATE some BARC exam and all exams, if also you may be appearing, na? Engineering services prelims, BARC exams, or the AE exams of the Langina. So this crash course will be helpful for other exams also. The fee is 5499. If you are an old previous OHM student enrolled into any course live or offline, okay, the fee will be 3499. And if you're a current this year OHM student, any course offline or online, the fee will be 2499. Okay, with this course you'll also be having the free online test series provided automatically, and the course starts 24th November. But if you decide, and if if you're sure, and if you register up to 20th of November, okay, that is just tomorrow, okay, you get additional 10% discount. Okay, you get the additional 10% discount, right? Okay, this is what it is. So hope you liked the today's revision session. Yes, I'll some topic by topic I will run. Okay, probably next topic we can take is another important one, Z transform. Very important both for EE and EC, the Z transform. Okay, same way, we'll first revise a basic set of formula and properties, and then jumping to variety of questions. Okay, because questions can get you command, and last moment I think questions are more important in this revision phase. Okay. All right, okay guys, so as I told you, I'll share you the PDF, complete PDF with the questions and along with the previous formula slides, so that this becomes a quick revision guide for Fourier transform. But please note that all the PDFs that I share, this one and even the previous one, are password protected. Okay, because those who are putting the effort, those who are dedicated, those who watch the session, okay, of course, whenever you are watching the session, you see the password and then you have the access. The notes are for those who are dedicatedly following the classes. Otherwise, the notes are meaningless for you. Na? Okay, so what will be the password for today's PDF? The password for today's PDF, some frequency discussion happened. So the password for today's PDF will be frequency. Randomly, I just crafted. Okay, so please note down everybody, the password will be frequency, because I'll share you the PDF in the Telegram. I'll again share you the Telegram link. Okay, the PDF will be shared in the Telegram. Okay, this is the link of the Telegram. I've again shared in the chat box. Okay, if you're not connected in my Telegram, you can join there. I'll share you the PDF. Okay, maybe by tonight or tomorrow morning. Okay, I'll try to send it tonight, or otherwise tomorrow morning you will get it. But don't worry, you will get the PDF. Okay, with a small password protection. The password will be frequency, everything in small. So do note this password somewhere so that you access the PDF comfortably. Okay, so that's it guys. Thanks, and let's plan another session. Okay, so we'll plan the next session mostly on Z transform first. Okay, the next very important area out of this subject. Okay, important for both EE and EC. Okay, bye bye, good night, thank you, stay safe and do